the I²CNER seminar. And my name is Takahara. I'm the PI of the I²CNER. And today we have a guest from India, Professor Rao. And he's a very world-famous scientist. And now he's a national research professor and honorary president, Linus research professor, Jawaharlal Nehru Center for Advanced Science Research, India. So I think you can read his CV in this detail. And also another side, one of the I²CNER researcher, he has this article which appeared in a newspaper, Japanese newspaper, in 2008. And the Japanese researchers, you can read through it.
What is it about?
And you are the pioneer of the material research, and you are eager to encourage young generation. So that's what this explanation. And also, as mentioned about your CV. And today, this time we have I²NRS ICA 2014 at Fukuoka University. And so now the chairman, Professor Suzuki, is there. And he's, in spite of his busy schedule, he also come to attend this meeting. And also Professor Takagi, and he is the president of the I²NRS. And he also come to attend this meeting. And today I have Professor Rao came here for plenary talk of the I²NRS. And also we have a vice president of the Indian MRS India. So Professor Shaw.
Rupali.
Sorry.
Chaudhary is
sorry. And so today we have these two guests, and on the occasion of this just this morning he finished his plenary talk, and today he'd like to give us a message for young people. And Professor Rao will give a talk on the materials science research in India. So, yeah, please.
Okay. Good afternoon. Very rarely I give talks on a very general topic of this kind, but I'll try. One or two points of history I would like to say before anything. You see, India is a very old country. It is a history at least about 5,000 years. So, it's a very old country. What is interesting is, even 2,000 years ago, 2,500 years ago, even though we did not know chemistry, metallurgy, or material science of today, Indians did a lot of interesting things, like metallurgy, alloys, all kinds of alloy casting, all kinds of things out of metals, amazing things. Even today, when you look at how they did the casting of that kind. Particularly interesting was that the famous story of Damascus sword. You must have all read about that. About 2 years ago, the Damascus sword is supposed to be the strongest or the very, very sharp edged sword. It could cut a hair into pieces, it could cut another sword also. Very, very strong. And Peter Prof in Munich has analyzed the Damascus sword, why it is so strong. And he found that it is made of a particular steel. And that steel had carbon nanotubes inside that. And this was done maybe 1,000 and odd years ago, the Damascus sword. And the steel was first made in India. Damascus sword made up is known as the Woods steel. Woods steel was an Indian production about 1,000 and odd years ago. And they used to make the steel over fire from coal and firewood and all that. And the flames always took a lot of carbon particles. Obviously, some carbon particles crystallized into the form of a nanotube while making the steel. But this is not, they didn't know that. But it is very interesting to me that historically, the use of carbon nanotubes in alloy making or making steel is as old as wood steel. Wood steel, that was about 1,000 years ago or so. And that was very surprising that this article came out in Nature magazine some time ago, where Peter Popper's work on electron microscopy and other analysis of the Damascus sword. The reason I told you about these stories is because even though it's an old country, India, but you see, you will understand that unfortunately we had a very bad 300 years of domination. We became a colony. We were a colony of the British for almost 300 years, and very little science was allowed. Science was allowed. They had colleges only to produce clerks for the British government and not to produce scientists from India. So it was like that. But anyway, the first Institute of Science in India was started 105 years ago. And that's where he works there, Indian Institute of Science. It was the first Institute of India doing research. I was the director of that institute some years ago. I was also a professor there. I was the head of that institute many years. It is still the oldest institute. In fact, it is one of the earliest institutes to start metallurgical engineering. There was another university in the north, in Benares, which also started metallurgical engineering. There was no material science as such. So these are all these old institutions. Indian Institute of Science, even today, is one of the best institutes of India for research. It has 1,400 PhD students and many others who do master's degrees and so on. Well, what happened in material science as we understand today? Modern material science, which is not metallurgy, it is not ceramics, but it is something more than that. So many institutions in India started having departments for metallurgy, ceramics, some 40, 50 years ago. But it's only last 30 years to be exact, roughly 30 years, that material science as we understand today has got recognized as an important subject in many institutions. So there are many places now where they have departments devoted to materials, and some institutions like Indian Institute of Science have centers for materials research. We have a materials research center at the Indian Institute of Science, and similarly my center has an international center for material science and so on. Well, what are the main areas? Today in India, people are working in a number of areas, the electronic materials, composites, nanomaterials and so on. And then, before I talk about the areas, let me tell you about the institutions. What are the major institutions in India? We have a big national laboratory for metallurgy. We have a national laboratory for metallurgy. Just like you have here, many national laboratories. Indian Institutes of Technology. There are 7 old IITs or Indian Institute of Technology. Most of them, or all of them, have departments related to metallurgy and materials, particularly the older ones like the IIT in Bombay, in Kharagpur, IIT in Kanpur, a few places have metallurgy, material science as subjects. So there are many people, their undergraduates can study for 4 years to get a bachelor's degree in this subject, and then there are a lot of people who do PhD and also master's degrees. So these are all the facilities. And in the last few years, I must say, facilities in India have improved. You may not know that there were 30 years ago, or 35 years ago, in entire India, you could not see electron microscopes. There are not many. In the Indian Institute of Science, I got the first good electron microscope when I was a professor there. That was about 35 years ago. Before that, there was no good electron microscope. Most institutions have good facilities for material science research only in the last 30-35 years. So that's why materials research is relatively new to India, but it has now caught on fairly well in a number of institutions. And today, of course, there are many institutions with very good facilities. In my own center, we have at least 3 major electron microscopes, including a Titan microscope with the aberration-free microscope, and so on. So facilities are increasing. And in doing that, there's a slow recognition in our government, particularly in central government, that advanced materials is a very, very important area that we should support. It was not like that before. It's only now, in the last few years, that advanced materials research is getting more and more importance, and India will invest more in materials research for many years to come. In my own center, I'm in the Center for Advanced Research. We have a number of PhD students, not very large, maybe 60 or 70 PhD students in this area. We give what we call the integrated degree for PhD. There are people with undergraduate education in science can join. In 5 years, they get a master's degree and a PhD degree in material science. So we give such degrees. We also give people who are engineering degrees or people who have master's degree in science a 2-year research degree called MS in research in material science. These are all the new things, and we have a number of other programs I'll come back to later. Well, a few years ago, about 10 years ago, as you know, the entire world became very big in nanomaterials and nanoscience and nanotechnology. India started a very reasonable program in nanomaterials, nanotechnology about 10 years ago. At that time, except a few people, in my lab, myself, maybe 1 or 2 others, used to do work on nanomaterials. In fact, the number of publications from India in nanoscience and nanotechnology about 10 years ago would be very small, except there are a few people who worked on that. So what we have done, therefore, we created a national nano-mission. I am the chairman of that. We have funded many, many institutions. We have created facilities for materials research in a large number of institutions. Not only for individual, but institutions. We created, for example, illuminations, electron microscope, or all kinds of atomic force microscopy, scanning microscopy, whole bunch of facilities, a number of facilities, several places. So suddenly in the last 8 to 10 years, research quality in India has improved, particularly in nanoscience. I don't know whether you see that in the last few months, there has been a report on how various countries are doing in nanoscience and technology. United States, China, Japan, and India are the top 4 countries. India is 3 or 4. India, Japan, China, and China is producing a lot of work now, and United States. So India is now the top 4 countries in actual number of papers coming out in nanoscience technology. So India is showing some results in investment, due to the investment made in areas of this kind. Well, in addition to that, what we have got now is a number of possible collaborations. We have, for example, my center, in the Jawaharlal Nehru Center for Advanced Scientific Research, has very close collaboration with some of the institutions, like Cambridge University in England, Northwestern University. Northwestern University, as you know, has a very, very strong materials program, and also a little bit with Purdue University. And recently we have signed an agreement with RIKEN in Tokyo. So we are having Tokura and Professor Nehru both came to our center, and we have an agreement of collaboration for research. with RIKEN in the area of materials. So this kind of agreements have been very useful, and now we have created in India number of network programs. For example, Britain and European Union along with number of Indian scientists, have a very major program in energy area and also in photovoltaics. Photovoltaics, organic, particularly organic LEDs and organic photovoltaics, there's a very major research program with Britain and with also European Union. And these are all the agreements we are continuing. In fact, Germany wanted to set up a program with India, an institution for materials. I don't think it has taken shape, but just recently we had a discussion with UK, and it is very likely that UK jointly with India, probably in Bangalore, will have a joint research activity, joint research center for advanced materials research. And my own hope has been that we must have something joint with Japan, actually. I just told the Minister for Japan, Minister for Science and Education from Japan, who visited us about 2-3 weeks ago, that we must do something together with Japan. And Japan and India should work together in advanced materials. And he seemed to agree with it, of course, we didn't come to a conclusion. But what we have done between India and Japan, many of you may not know, is the last 20 years, I was responsible from Indian side, and also Professor Saburo Nagakura, who was long ago professor in Tokyo University, and later he was in Okazaki, and then was also chairman of a university, graduate university, National Graduate University, and in Hamada, I think, forget that. And then later he became president of the Japan Academy. And Professor Nagakura and I started the Indo-Japan collaboration program. We have many meetings between us on symposia, seminars, Indo-Japan. In fact, the next Indo-Japan symposium is in Bangalore on nanocarbon materials, the graphene and so on. And D.D. Sharma, another colleague of mine, he has a number of programs with Tokura and others on oxide materials. So we have a number of joint symposia between Japan and India under the Indo-Japan agreement in science and technology in the area of materials as well. Well, I think this roughly tells you the present status of where India is. India has now recognized the importance of materials, but we have to invest more. Our real problem of India now is we are not investing enough on scientific research. We have to invest more, and I hope we have a new government. The new government will invest much more in advanced science and technology, including in the area of materials. So what are the priorities that we have in India for research? I would like to spend a few minutes on that. Well, you know, if you take the world at large, everywhere, as I saw in this building this afternoon, everybody is interested in energy area. So everybody wants to do something in energy. India is interested also in water. I'll tell you what I mean by water research. Energy, water, environment, these are the three typical areas. So what in energy am I talking about? What do you mean by energy? Well, you know, India's requirement, I hope you all know that, the estimated requirement of electrical power or whatever power in India by the year 2030 or 2025, that is another 10-15 years, is 400,000 megawatts of electric power. 400,000 megawatts. Well, how do you make that? Where do you get this power? It is very difficult. So hydroelectric, we are doing a lot of hydroelectric power installations. Well, the people say nuclear. Well, you know, nuclear, even if you very optimistic, you may get 20,000, 30,000 megawatts of power. It's less than 5 to 7% of India's requirement. And then what people are saying, what about photovoltaics? So everybody is talking about. So as you know, I hope you all know that China is flooding the market with their silicon cells all over the world, everywhere. It's going to be blood actually. That is photo cells from China. But anyway, so we can have photovoltaic. But you know, just now we have now decided India will reach at least a target of maybe 20,000 megawatts of photovoltaic power, say in another 5 years or 6 years. But I hope they will reach it, but I'm not sure. Even then, even if they reach 20,000 megawatts, it is less than 5%. It is 5% of our requirements of energy in the country. So that is where I see we need to have completely alternative sources for at least running our transportation, cars and planes, cars and trucks and all that. There is no doubt about that. Even photovoltaics, they were using to supply to the grid system. Even if we do that, the amount of power that will come there, it cannot exceed more than 10 to 15, maybe 20%. And it's very optimistic. It's not going to reach 20%. It will be much less. So organic photovoltaics is a big area of research in India. As you know, Richard Friend is Richard Friend in Cambridge, who is a leader in the subject, is also a very close friend of mine. He comes to Bangalore a lot. There's a big collaborative project. And there are a number of groups working on organic photovoltaics. I don't know whether and other related technologies. I'm not sure whether it will solve India's energy problem, but certainly it is an area of research. But India, therefore, is really concerned about energy as a major area, and they want material scientists to do something. There's no question about that. So I'm now urging the government to start an energy mission, energy research mission in India, national. Just like Nano mission, which was very successful. I hope energy research mission will be very successful. Well, I tell you what we mean. Suppose you take hydrogen. Hydrogen, I think, suppose we succeed somehow using hydrogen, storing hydrogen in some way. Well, we have to still make hydrogen, and there is a lot of research one can do based on semiconductor structures or other way, artificial photosynthesis, number of possibilities, and we have to invest more in hydrogen in India and many other related areas of energy, and in addition to organic photovoltaics and other areas of energy. So energy will be an important area for India. And I told you water. What do you mean by water? For those who may not know, 65 to 70% of the diseases in most of the developing countries, including all of Middle East, Egypt, Syria, Iraq, India, Pakistan, Bangladesh, Nepal, they all come from water. It is mostly waterborne diseases that have become, people don't realize, sitting in Japan or in New York, you won't understand that. I also don't understand because I have no problem. I live in Bangalore and everything is different. But so we have to provide drinking water which is very pure, safe to every person in the world. And if we want to do that, what is the technology we use? It is a very serious problem. Well, a lot of nanotechnology has been used. In fact, 2 or 3 new technologies developed by one or two by my own former students have become technology. Now people are using purification of water by these technologies. But it is required at every level. You know, imagine every village person. There are 60% of Indians are in the rural India, villages. I hope you know what 60% means. It's a very, very large, in terms of millions of population. I hope you can imagine what we are talking about. I am talking about nearly 600 million people in India are in villages and they don't have water. They have water. And this is a challenge for India. This is the challenge I propose to the government. If you want to do something for India, the majority of the people must have proper transportation, proper drinking water, so there are no diseases. So nanotechnology has been used to solve some of this problem. And another problem in water is there are areas of India where water is terribly polluted. There are areas in India where there is excess fluoride ion in some places. There are other places where there is excess arsenic. There is a third area where there is uranium in water, the north. In fact, there's a problem I have been associated with the atomic energy program in India, so I know these details. Is amazing. How do you what do you do about getting rid of uranium in water in northern India, in Punjab, or arsenic in Bengal, chloride in Rajasthan? So these are all not small problems. These all require problems that it is not enough to solve this problem in the laboratory, but you have to build plants which will actually produce safe water for all of you. And this I'm giving you an example of what other challenge of India. India challenge energy, water. Of course, environment is a problem too, everywhere. Where India being a populated, we have got 1.2 billion people. And you will have very soon 1.4 billion people. We will end up 0.5, 1.5 billion. By the time all of you become old enough like me. You see, I won't be around when that happens, because I'm now 80 years old. In another 20 years, India will have 1.5, 1.4 billion people. So we imagine the problem already. We have additional couple of hundred billion people. It's a large number. How are we going to solve the problem, not only of energy and water, but also of environment? The carbon dioxide problem is very severe, and we are fooling around with the carbon dioxide problem. The entire world is fooling around. There's no doubt about it. No real solution has ever been found. And what we are doing, a little research in the lab. I'm very glad to see today some research being done here on CO2, but it's some more serious, much more serious. Conversion of carbon dioxide into useful things, reduction of carbon dioxide to carbon monoxide, whatever you want to do. The whole, and in fact, eventually all carbon dioxide will become inorganic carbonates. How will you use inorganic carbonate to produce hydrocarbons or whatever you want to do? There's a very whole bunch of problems I can think of related to carbon dioxide. So India is going to be a center for that. We will face a very serious problem of energy, very serious problem of carbon dioxide. In that, again, I want to tell you about about water. You see, water, many of you may not know this. There have been very nice articles that have come in international literature in the last couple of years. The future wars will be based on water shortage. Water shortage is not a very severe problem in India and many parts of India. It is not only good water, it is lack of water. So, you may not know, many of you may not know this, the desalination program started in the world. It became quite interesting. About 45 years ago, 50 years ago, the membranes, the Canadian prepared the first membranes. One of the men who was involved with the man from Madras, South India, called Soviraj membranes. He was one of the first who made successful membranes which became commercial, Canadian, in Canada. And since then, the progress made seems to have been so marginal. See, people are in Madras, if you go to Madras, because Suzuki goes to Madras. Madras has no water actually. If there is rains fail, they actually have to import water from different places to drink. So desalination of seawater is a very burning problem for India. Everyone agrees, but nothing much happens. Everyone, recently our space, one of the laboratories in Chennai, you don't have to be there, they have got some sort of sublimation process, some expansion or where that happens, and they say they can make 1 million liters of water. It's all been shown, but they all have to become commercial. You have to commercialize water for drinking for India. One is pure water, that's what I safe water. Another is quantity of water. Actually, in Bangalore, again I'm old enough so not to worry, you may not know this, let me tell you, the rate of growth of Bangalore city is the highest in the world. It has been 18 to 20% per year. That in another 5 years they have doubled Bangalore. And the number of multi-story buildings that have come in Bangalore is something you cannot believe in Bangalore today. There was not even one multi-story building in Bangalore 15 years ago. Today is only multi-story building. Everywhere, you go to my campus, my laboratory center, everywhere you see these buildings. And none of them has water. It is amazing actually to see trucks actually going with water, supplying to this multi-story building in a center, filling their tank trucks going with water. So there is no natural water supply. They are short. So the reason I'm telling you is we means all over the world, we have to realize the problems of mankind are going to be very severe. One is energy, carbon dioxide, environment, water, shortage of water, clean water. Both these things are going to be the problems. So India has to work on these things. Well, the last problem, not the least, is that India, I told you we have a population of 1.5, 1.4 billion in 20 years. Fortunately, 60% of them are young people. I hope you know that. It's the opposite of Japan. Japan, too many old people. India, 60% are below 30. This will continue till the year 2060. So for another 40, 50 years, India will be a young country. When the rest of the world is old. So India is now facing a problem. What we have to do something about young people. Give them better education, better opportunities, and material science, suppose it has nothing to do with it, you may say. Maybe material science is going to be a part of it, but it is a very serious problem India has to face. How to do something. Lastly, this is something I didn't want to talk about, but being honest, I want to tell you. You in Japan should know, and we in India know, there is very, very severe competition in the world. Well, Japan knows that. In fact, I was just talking to some important people in this country. Others are coming up. Among the neighboring countries, China is coming up in a very big way. Korea is coming up in a very big way. And where do we belong? What has happened to us? It is a very severe problem. In the area of materials also, this will be felt. In the area of material science and technology, itself the competition is becoming so severe already that people are taking away the markets. So whatever is to earn money for our countries is being taken by new people in the business. As you know, I was involved in a committee as a chairman about silicon solar cells. This was 25 years ago. There were very few people who made solar cells. In Japan, there were two companies making, and Motorola used to make something in America. And today, all these companies are the world is surrounded by Chinese solar cells. So how things can change? So the reason I'm telling you is this is a problem India is facing. The poor country, big country with a lot of talent, they are investing more. We are not so poor that we can afford many things. We can get everything. We have enough money. We have big GDP. But what is it we should do to compete in advanced technologies, advanced materials? We put it in that. We have to learn to compete and succeed with this competition. And this is where I think the future of India will depend on. And how India will decide to compete, how India will give the right direction to our young people like this young man here, Harish. Yeah, we have to show them a direction. And then only will be India has a thing. Before I close, I must say something I really believe in. I've been a very great supporter and believer in Japan for many, many years. I have a lot of connection with Japan. And I was telling your minister when he came 2 weeks ago also. We in India and Japan have to work closer, much closer. We are two democracies. We have to learn to be the closest friends in Asia. We don't do that. We don't work together, India and Japan, very closely. The future will be a very different. I don't want to say why and so on. You can think why I say. Because the forces of the present world are such that we will not be able to survive and we will not be able to succeed in competition unless I think Japan and India are the obvious two countries to work in Asia today. And we should do that. This includes advanced materials. The reason I've been always trying to have an Indo-Japan advanced materials joint center or joint institute. I think it would be nice to do that even now. I'm on the advisory committee of NIMS for many years, some years now. But I wish somewhere we can have a joint center of Japan and India. It would be very, very nice. That would be very good. So what I'm trying to do in this afternoon is to give you a historical perspective of India, how subject has developed, how India has changed, and what we try to do. Don't forget that India of yesterday, India a few years ago, where I was born, you may not know, when India became free, got freedom on August 15, 1947. I had just entered college at that time. I was very young, but I just entered college. I still remember the day India got freedom. But from those days where India had poverty, you may not believe it. I went away to America to study. Came back from America. Then if you want to go abroad, they would give you $8 as exchange to go abroad. $8 in the bank. That's all. There was no dollars available in India. That was 50 years ago. And did not know how you can get any number of dollars. So the question is, we have come from absolute poverty. Such poverty you won't know. You know, there was a rationing in India when India got freedom for food. Only so much rice per family. So many cloth was rationed. In Madras city or Bangalore city or Hyderabad city, anywhere, everyone put enough cloth for 2 shirts. And you know, one small piece of cloth for something else. 2 plates of pie, maximum per year. You know, unbelievable. In fact, even though when I say this, nobody believes me. It is true, that's how it was. And that India has now become world's 4th economic power. One of the top economic powers, in spite of all the top. So even now, you see, this is the thing. India is a rich country, but also a poor country. With GDP as income, but there's a lot of poor people. So India has to have on one side, we have to go on progressing, industrialize, compete, commercialize products, work with countries like Japan, and so on. Another is taking care of poor people who are behind. We have to do both. So it is this challenge of India, where advanced materials technology as one of the tools in the solving problems and many other scientific and technological solutions we have to find. I hope India will succeed in 20, 30 years. It is unlikely I will be alive at that time, but most unlikely. But I hope India and Japan will really thrive in another 10, 20 years as two major powers in material science and technology and in energy.